Hi, this is Julie, and in this video I'm going to talk about different types of integers and what happens if a number is too big or too small for its data type. This is also known as overflow and underflow. Most of the time, when we're working with integers, an int data type is large enough. An int's value is usually going to be about -2 billion to +2 billion, so that will cover a lot of situations. But sometimes that isn't going to be what we need, and so here is a listing of the different sizes of integers and their approximate range. Now, when I listed the range for these, I put rounded numbers because I don't think it's beneficial to memorize the exact range on these, but rather if you just know roughly how big of a number you can put in these different data types, then you'll know if that's the right data type for what you need. Now, char isn't something that we really think of as an integer, but technically it is because it is storing an integer value. It has a very small range because it only uses 1 byte of storage. The next data type is called short. And a short uses 2 bytes of memory, so its range is from about -32,000 to +32,000. And then the third size is usually used by 2 different data types, int and long. And I'll come back to int in a moment. But this data type ranges from about -2 billion to +2 billion. And then finally we have the long. So if you're working with numbers that are bigger than 2 billion, you might want to consider using the long. It's using twice as much storage, so you can use numbers that are between -9 quintillion and +9 quintillion. And that's 2 to the 63rd power. But let's go back and revisit this idea here about int. The middle 2 data types are really represented, or middle 2 sizes rather, are represented by 3 different data types. And that looks a little strange at first. Well, when I first started programming with C++, the environment I worked in had ints that were the same sizes as shorts. And so if I needed a number that was bigger than 32,000, I had to use a long. But in modern compilers and everything I've seen recently, I've seen that an int behaves more like a long. And so for today, you can probably assume an int will be the size of a long. But in the standard, it's not required to be. So you could find an older environment or an older compiler where an int is only up to about 32,000 or using 2 bytes of storage. Now you also might want to know, why do we even have this short and why do we care? And with modern systems, we're usually not too concerned about the limits on our memory. And so we're not really worried about conserving memory. But if you're working in something with embedded systems where you do have a very constrained environment, you may be needing to be very conscious of the memory you're using. And if we want to further extend the upper range of numbers, we can use unsigned data types. And with these data types, we're no longer storing a bit or using a bit to store whether a number is positive or negative. So now we can have an upper range that's twice as big. And this is what these are going to look like. The data types have the same names, but now the word unsigned is in front of the data type. Now you can't put negative numbers in the data type. Instead, the range begins with 0, and then the top end is going to be double what it had been when it was a signed number. So now, if you're working with an unsigned end, you can use a value of up to about 4 billion, or you can move to unsigned long if that's not going to be big enough for you.